So a group of researchers will go through and comb through all the studies in the topic. They will collate all the relevant ones that fit the right model and have the right data sets and so on. And they basically concluded that based on all the research available now, or up to at that point, this was back in 2015, that intestinal permeability and the resulting chronic low-grade inflammation, a lot of it induced by stress, right? And this is something that they focused on, was the number one cause of morbidity and mortality worldwide. That's the number one killer of people, right? Stress, chronic leaky gut, chronic low-grade inflammation. That sets you up for all other manners of disease. And so what you were saying earlier of people feeling like I don't have a gut issue because I don't bloat, I don't have diarrhea, I don't have constipation, that's just one small dimension. If you're having all those symptoms, then not only do you absolutely have a gut issue, but you've probably had one for way longer than those symptoms have shown up, and other things are starting to get dismantled in your body. If you don't have those gut symptoms, if you've had any skin issues like acne, eczema, rosacea, right, psoriasis, you have a gut issue. If you have anxiety, sleep issues, if you have depression, you have a gut issue. If you have brain fog, if you have low energy, any of those things, you have a gut issue, right? The gut, if you have metabolic syndrome, if you're overweight, you struggle with weight, or you're underweight, you can't put on weight, all of these things are a gut issue. And the gut is a central command center. And if your gut is dysbiotic, it'll manifest in many different ways.
So let's describe what leaky gut is, because I throw the word around a lot, and I always talk about it all starts in your gut, whether it's weight gain or your heart issues or your anxiety or depression, just like you're talking about. All of these chronic issues start in the gut. And something I want to make sure we emphasize is what you said about it being just one meal. So you can say, well, I just had one cheat meal this week. Well, that one cheat meal, the calories are in and out, but the ramifications that are left behind for when you actually eat your healthy meal, there's a cascade of issues, and it's unfortunate. And we're just the messengers. Don't shoot us. It's not that fair. Yes, I agree. It's not fair. You can't go out and have Ben & Jerry's and a pizza and be fine the next day. But so let's get into what is leaky gut and why can't we get away with those cheat meals just once in a while, and how it affects the rest of our daily intake.
Right. And I'll add to that, if your gut is leaky, you absolutely cannot get away with it, right? If you've built resilience, your gut is not leaky, then you likely can get away with it from time to time. And that's really the goal, to me, at least from a health perspective, is building resilience, because you're never going to make 100% the right choices, nor will all those choices be within your control all the time. So you want resilience within your system. So should you encounter something like a new virus, or should you be in a place where you can't eat anything but something that's not healthy for you, you're able to do those things and be okay. But that's if you build resilience, right? The people with leaky gut, that one meal is going to cost them 2 weeks of inflammation. But then at the same time, and by the end of that study, the treatment group had built such resilience and stopped leakiness in the gut. We gave them the same gas station pizza horrific meal, and they had no endotoxemia, no inflammation, no leaky gut from it, right? So you can build resilience, and that's a really important component of this. So let's talk about what leaky gut actually is. Keep in mind that your intestines, your gut, as we call it, have to be leaky to a certain degree, right? They have to be selectively permeable, because you have to let a lot of things through. The vast majority of nutrients and everything that we get into our system goes through our digestive tract, from things we eat, we drink, we swallow inadvertently through breathing it in, and then it being driven back into your digestive tract, or things that enter your eyes or your ears. Everything drips into your throat eventually, and you swallow it. And so most things your body encounters are going to go through the digestive tract at some point. And there are things that your body has to let through, like nutrients, for example. All the vitamins, minerals, fats, proteins, carbohydrates, amino acids in the case of proteins, those have to get through. But you don't want toxins and antigens and viruses and all of those things getting through either. And so your gut has to become selectively permeable. And there's a couple of structures in place to allow for that selective permeability. But as it turns out, those structures and how they function are largely dictated and controlled by the microbes that are present there. So if the wrong microbes are present, then that whole structure doesn't function and your gut becomes incredibly permeable, not selectively permeable, right? So let's talk about the structure for a moment. If you look at your small intestine, where a lot of absorption and all that happens, you've got this mucosal layer, and then you've got all these microvilli, right? All these finger-like projections. You've got all these villi and microvilli on top of it. And the whole point of that is to add lots of surface area to the small intestine. So you have a lot of surface area for absorption of nutrients and food. Because as the food moves through the small intestine, it takes time to break down and digest the macromolecules into the micromolecules that you can then absorb. So in order for you to absorb things properly, you need time and you need surface area, right? So this is why emptying of the small intestine is slowed down. Things jump out of your stomach relatively quick once you eat. It goes in the stomach, gets mashed up, hydrochloric acid is added, and then it's dumped into the small intestine, and then it sits in the small intestine for a few hours before it can move on to the large. And that time is needed and the surface area is needed, right? So you've got this villi, microvilli, and then you've got this mucosal layer sitting on top of it. Now the villi, the lining of the villi is made up of your intestinal epithelium. This is a single cell thick layer of cells kind of sitting shoulder to shoulder, right? And if you think about it, this is the biggest barrier in your body. And it's the final step of something actually being inside the body, right? When you swallow something, it's still outside of the body technically, because your digestive tract is a tube that's open on both ends, right? So it can pass right through, means it never actually entered your body. For it to go inside your body officially, it has to go through that mucosal layer, past that intestinal epithelium, those single cells, and then enter into circulation. Now, the circulation that's at the bottom of that is called the basolateral circulation. Most of what enters there, about 85%, goes first to the liver, and about 15% ends up in general circulation, right? But the things that go to the liver is so that the liver can decide what to do with it, metabolize it, conjugate it, neutralize it, so it doesn't become problematic for you, and so on. So you've got this lining that has the mucosa, that has all the microvilli aligned with single cells. The cells sit shoulder to shoulder because when nutrients come through, some nutrients can pass through the cell, right? That's called a transcellular pathway. The cells are designed to have an osmolarity gradient. So things like magnesium and calcium and things that have a charge to it can easily just pass right through the cell, end up at the bottom in circulation, right? No specific carriers or anything needed. These are important things. We need them all the time. So bring them in and let them pass right through. Then in between the cells, there's a space, and that's called a paracellular pathway. That's for bigger things like amino acids, like proteins or glucose molecules and so on, or nutrients, right, that have to pass through. So the cells have to be able to open up and stay open for things to go through, and then cinch up and close when we don't want things to go through, right? Now, the control mechanism of opening and closing this is done by this lattice of proteins in this tight junction. These are called claudin and occludin proteins. What they're called is not important, but just know that there's this lacing of proteins in between these cells. The proteins can loosen up to open the cells, things will go through, and then the proteins tighten up like laces and close the cell back up, right? So that keeps the intestine from getting permeable. Also keep in mind that mucosal layer up top slows things down when they're moving through. You swallow something, you start digesting food up here above the mucosal layer. You've got big chunks of carbohydrates and proteins. Your enzymes go in and they break it all up, right, into smaller glucose monomers or fructose or amino acids or vitamins. And then all that stuff is sitting up here, and it all is going to flow through into the lining, but the mucosal layer slows things down so it doesn't flood the system, right? So things then slowly move through the mucosa, which is like a jelly-like structure. And in the mucosa, this is where something very, very important happens. Your immune system is monitoring what's coming through that mucosa. And this is where your immune system decides, is this a bad thing or a good thing, right? Are we going to attack this thing coming through, or are we going to tolerate it? Now, the immune system doesn't actually know what's bad and good. The immune system is relying on the microbiome sitting in the mucosa to translate for it what is bad and what is good. So the microbes are trying to tell the immune system, hey, this is coming in. This is protein. It's totally fine. You don't need to attack it, right? Or this is a microbe. We've seen this microbe a million times. It's not really an issue. You don't have to attack it. Or, holy cow, here's a virus. You need to pay attention to this. Go ahead and attack this. So it's that crosstalk between the microbiome and the immune system that's constantly happening in that mucosa. And that's where a lot of the decisions are made for how your body is going to respond to things, right? So your tight junctions have to be sealed. They have to open at the right signals to let molecules through. And then certain things can pass through the cells. And then the mucosal structure has to have good integrity. You have to have good microbes in there speaking to the immune system, training the immune system what it should pay attention to and what it shouldn't pay attention to. If all of those things I just said are working properly, you won't have any issues, right? You can eat almost anything you want, right? You will have few immunological issues. You'll have very, very little inflammation. You'll have resilience. Your gut will be strong. You'll have perfect bowel movements. Your immune system will be working in tip-top condition, and so on. Now, the problem is in the vast majority of people, certainly the 55% of those 20-something-year-olds that we tested, many of those things are dismantled, right? And the dismantling starts with having dysfunctional bacteria in that mucosal layer, right? So what starts to happen if you have dysfunctional bacteria in that mucosal layer, there's two main things. One is you don't have the microbes that elicit the gene responses that maintain the tight junction proteins, right? So you start getting too many areas of your gut lining where the tight junction proteins dismantle and then the cells stay open all the time, right? So now that part is leaky. You also will get a situation where you have too many pathogen-like microbes in this mucosal layer that themselves are eliciting an immunological response. So there's constant inflammation in that mucosal layer. And that inflammation in the mucosal layer will also eventually start damaging the intestinal epithelial cells. So not only will you have cells that are open, you'll also all of a sudden missing cells. Because when the cell gets damaged through inflammation, it gets kicked out of the line of shoulder cells sitting shoulder to shoulder. And now you've got cells sitting like this and then a gap where one got kicked out and it's not being replaced effectively, right? So now you have a full gap there in your gut. You've got tight junctions that are open. You have actual gaps in the gut. And then the other problem that occurs is the microbes that are dysfunctional, that are driving inflammation in the mucosal lining, that are not speaking to the immune system to try to help the immune system decide what to attack and what not to attack. Those microbes are also not helping maintain the mucosal structure, because the integrity of the mucosa is also dependent on good beneficial microbes, right? And we could specify what kind of microbes if that's important, but just know that a healthy microbiome is what maintains that healthy mucosa. So now this mucosal layer gets thinner and thinner and thinner over time. So the ability to slow down the influx of things penetrating through gets diminished. So then every time you eat, things rush through. It's like a flood, a tsunami, if you will, of things, right? It could be nutrients, it could be microbes, it could be anything. And then your tight junctions are open, you have big gaps in it. So those things are all leaking through. And at the same time, because your microbes in that thin layer of mucosa aren't communicating well with your immune system goes into panic mode because it thinks you're going to get trillions of microbes moving through. So everything that comes through that region gets an inflammatory immune response. There's no communication of, hey, tolerate this, don't tolerate that. Everything gets an immune response. So what you start to feel is intolerances, right? Things you used to be able to eat. You know, you used to be able to eat dairy to a certain degree and be fine. Now dairy creates massive GI issues for you now because your immune system's attacking the dairy protein because you don't have the microbes there to tell the immune system not to do that. Right. So now you've got a very inflammatory, hyperactive immune response in the gut lining. You've got microbes that are dysfunctional, that are not repairing the mucosal layer, that are not repairing the tight junctions, that are not inducing the repair of damaged intestinal epithelium, that are leaving gaps in the system. And many of those microbes themselves will produce toxins that drive this inflammatory process. Now you can't properly absorb nutrients. Your immune system can't discern good from bad. You've got all kinds of things leaking through into circulation. A lot of it, 85% of it that goes into that basolateral circulation, remember, goes to the liver first, right? So now the liver is dealing with an unusually large amount of toxins that are coming through. The liver gets damaged. This is why you start to get fatty liver disease, right? That's why many gut issues are also associated with a very high prevalence of fatty liver disease, right? So we take SIBO, for example, right? Something like 48-50% of SIBO patients have liver dysfunction, right? Compare that to non-SIBO individuals of the same age, it's like 7%, right? So you're almost 7-8 times likely to have liver dysfunction if you have SIBO, because that dismantling of the gut structure goes hand in hand with overwhelming the liver. And if you overwhelm the liver, your bile acid pool that the liver is producing for you gets reduced. So you're not producing enough bile through through use during digestion. So now you can't absorb fat soluble nutrients like vitamin D, vitamin K, vitamin E, and all that. So you become nutrient deficient, and you can't actually control microbial growth in the lining of the gut because the bile acts as an antimicrobial. And part of its job is in the small intestine to maintain a low level of bacteria. So now you get an overgrowth of bacteria happening in the small intestine. A lot of those bacteria are dysfunctional, because that's what started the process. And a lot of those are producing toxins that are leaking through in a profound way and creating chronic low-grade inflammation in the individual, right? So your digestive health is not working right. Your immune system is going haywire because it has no communication. So it's just attacking everything. And what the gut immune system does, it translates to the rest of the body's immune system. So now your immune system in your mucosa, in your respiratory mucosa, or in your vaginal mucosa, or your skin mucosa, are attacking everything it comes in contact with. So now all of a sudden you're developing chronic sinusitis, or allergies, or chronic BV, or chronic yeast infections, or eczema, or psoriasis on the skin. These are all inflammatory conditions being driven by a dysfunctional immune system that starts in the gut, right? And then you also have chronic low-grade inflammation throughout the body. And chronic low-grade inflammation is the number one driver of chronic disease. That is what sets up virtually every chronic disease there is. This is why that study concluded that chronic low-grade inflammation as a result of a leaky gut was the number one driver of morbidity and mortality worldwide. It's the number one cause of disease and death worldwide, right? So that is how the whole system starts to get dismantled. When your gut is leaky now, your brain becomes very susceptible to a significant toxigenic attack that then sets you up with anxiety, depression, or in young kids, behavioral disorders, spectrum disorders that eventually leads to Alzheimer's, dementia, and so on.